It is common knowledge that computers communicate in binary. They use the binary number system. And if you're like me, you probably ask the question, why? Because decimal system just makes sense to me as a human, because I have 10 fingers. It makes sense to count in tens, but a human is not a computer. And somehow the entire digital world, every music, every video, every picture, every file, every OS is kind of mapped out and communicated via this binary system of zeros and ones. Let's break this down very simply. The computer is built with millions and billions and thousands of millions, billions of tiny, very, very tiny, tiny switches called transistors. And this switch can only be in two states. A transistor can only be off or on. So 0 and 1, true and false, two states, nothing more, nothing less. So the computer does not know banana or don't stress me or leave me alone. It knows on, off, on and off like Christmas lights. Now, how do we then convert our own human information into this on and off, zeros and ones state of the computer? We're going to take it one by one. Numbers, letters, videos, images, sound, audio, one by one. But first of all, the root is the bit, B-I-T, which is the short form for binary digits. So 0 is a bit, 1 is a bit, but a bit can only represent two values, 0 or 1, that's a bit. And that kind of leads us to the idea of bytes. Now, what is a byte? We can think of a byte like a tiny box. Inside one byte, we have 8 bits. So the box contains 8 bits, and a byte can represent 256 possible values. So from 0 to 255. 2 raised to the power 8 is equal to 256. So a byte can hold 256 possible values. And that makes it more useful in conveying the information that humans want to convey to the computer, as opposed to bits. So if we combine thousands or hundreds or millions of bytes, then we can have valuable information, right? Now let's get a little bit more practical. How are numbers stored? Let's start with positive numbers. If you want to communicate the number 39 to the computer does not understand 3 or 9. If I say 3 and 9, because I'm human, I understand that this is 39 instantly. The computer doesn't, and it must convert it to binary. Because, like we said earlier, binary is the computer's native number system. So if the computer wants to store the number 39, it will convert it to 001001111. So if I type in 39, the computer is seeing all of this instead of 30. In the same way, every number that you store, that you use, your age, your account balance, your account number, your phone brightness level, every number that you communicate to the computer or try to store is kind of converted to binary for the computer to understand. Now, what about letters and text? How does the computer understand or store uppercase A or lowercase b or uppercase D? It doesn't. It does not know or understand uppercase A, right? So how does it receive that information from us? The computer cannot even store letters, but numbers. So back in the day, when I didn't exist, some ridiculously smart people came together and came up with a system of mapping letters to numbers for the computer. And these very ridiculously smart people came up with a table called the ASCII table. ASCII stands for American Standard Code for Information Interchange. So, long story short, the table pretty much maps non-numerical characters to a numerical correspondence. For example, the letter A is number 65. The space character is 32. So when you type uppercase A, the computer is not storing uppercase A. The computer takes the number 65, which is the correspondence of uppercase A, and then converts that to binary to understand and to store. So if I type LO, all in caps, the computer points to 72 because age is 72, 72, 69, 76, 76, 79, which then in turns become binary. So that is literally how every text message, every tweet, every WhatsApp message, is processed and stored. So every text is basically just a long sequence of bytes, very long sequence of bytes. But then later, ASCII became too small for world languages. Think about it. We have English, but then we have other languages like Arabic, like Yoruba, like Estonian, all of these languages. And then we have emojis. And that was how Unicode was created, again by ridiculously smart people. But the principle is pretty much the same. Letters or characters mapped out to numbers and then converted to binary. Now, how are images stored? This one I find really interesting. Photos are not just photos. Photos are made up of millions of tiny, tiny, tiny dots or boxes called pixels. So if you take a random photo and you zoom and zoom and zoom and zoom it out, you would see, if you do this on a laptop, you would see tiny boxes. When you zoom it out to the utmost zoom level, you will see tiny boxes. Those tiny dots or boxes are called pixels. And if you look at it very well, every pixel has a color. And the colors are usually stored in RGB formats. RGB. Each of these RGB for one pixel has a byte. So 1 byte for red, 1 byte for green, 1 byte for blue. And that gives us 3 bytes per pixel. So each pixel that you see has 3 bytes. If we want to break it down, that is 24 bits, but we stay with bytes. So each pixel has 3 bytes. So if your picture is 1000 by 1000 pixels, that is 1 million pixels. And 1 million pixels times 3 bytes, that is 3 million bytes. And that is 3 MB. That's why your pictures usually would have sizes. Now, how are audio stored? How is audio stored? Sampling. That's the process. Audio is sound and it's pretty much vibration. So to store sound digitally, you measure vibration many times per second. It's like taking tiny snapshots of the sound. And each of those tiny measurements is called a sample. A common rate is 44,000 samples per second. And each sample is then stored as a number. Higher number equals to louder sound and lower number equals to quieter sound. And then each sample is then represented in binary. And that is how sound also becomes data that is able to be processed or stored by the computer. So in a way, just like text, audio is also just a long list of numbers that represent sound waves. Now, videos, this is the one I like the most. Videos are not just videos, they are pretty much images plus audios. So a video is just a bunch of image that you play really fast and audio is added to it. If you go on your iPhone, you probably see things like 30 FPS, frames per second, or 60 FPS. It means frame per second. So if I record a 1 second video at 30 FPS, it's just pretty much 30 images and audio. If I record a 1 minute video at 30 frames per second, that would be 60 times 30. That is 1,800 images and audio. I record a 10-minute video at 30 FPS, that's just 30 times 60 times 10, that's 18,000 images with video. So a video with audio rather. So a video is just a bunch of images. And each of those images is then stored the same way we talked about storing images. They are stored like images, pixels, 3 bytes per pixels. That's it. Plus the audio. And that's why videos usually we have large files, because it's a lot of images. Imagine we calculated the image from earlier, like, oh, if you have a 1000 by 1000 pixel image, that's about 3 million bytes. Now, think about it. If you then have a video that contains 18,000 of those images, that's usually why videos are large, because it's just a bunch of images and then add the audio on top, boom. So videos are usually compressed or else. So that's pretty much the summary of how it goes. Numbers, text, emojis, images, audios, and videos. That's the process of making the computer understand us. We see an image. I see an image and I see myself and I'm like, oh yeah, that's me. I'm so pretty. A computer does not see that. It has to go over this whole process of seeing each pixel and trying to map each pixel into bytes, and it's a whole thing. To wrap it up, computers only understand zeros and ones because they're made up of transistors. And when we have human information like numbers and text and images and audio and videos, they are all converted in a way to binary. It's crazy when you think about it. Everything. You can have like a 50 hour video. At the end of the day, for a computer, it's just billions of zeros and ones. Let me know if you enjoyed this video, and please like and subscribe. I don't know what I'm doing recording this video, because I actually have another video I want to record. I'm just too lazy for that. But this seemed like it was fun talking about it. So don't forget to like and subscribe and comment, and see you in my next video.